Good afternoon, class. Thank you. You can sit down. All right, then today we are going to continue the lesson on intersection and union. We'll be looking at a few more questions based on that. All right, in the previous lesson, I gave you some work and we have to complete question 2 because that was given for homework. All right, given that the universal set is 1, 2, 3 or contains 1, 2, 3, there shouldn't be 2 commas, 3, 4, 5, 6, 7, 8, and 9. The set A is 2, 3, 4, 5, and the set B is 4, 5, 7, and 8. List the following sets. Okay, the set we are looking, or we are trying to list is, right, number 1, A union A, the complement of A intersection B. Okay, the set A is given, the set B is given, we have to, and the universal set is also given. Okay, what we can do is work out what the set which is the complement of A. Okay, the complement of A will be 1, 6, 7, 8, and 9. Good. Complement of A means the elements that are not members of A, of the set A. All right. And A intersection B. All right, B is given to be 4, 5, 7, and 8. So the complement of A intersection B is going to be 6 is not, 7 and 8. Clear? All right, so 7 and 8. Now, from this we have to work out A union, right, the complement of A intersection B. Any answers? George, what's your answer?
Two, 3, 4, 5, 7, 8.
2, 3.
4, 5, 7, 8.
2, 3, 4, 5, 7, and 8. Okay, let's check. It includes all the elements of set A and all the elements of the complement of A intersection B. So all the elements of A are 2, 3, 4, 5. So that's correct, 2, 3, 4, 5. And then plus 7 and 8. Okay, so that's correct, 2, 3, 4, 5, 7, and 8. All right, number 2. Let's see if we can answer this without me having to do it on the board. B union, okay, in brackets, the complement of A intersection B. Any volunteers, Rita? Give us your answer to part 2.
4, 5, 7, and 8.
4, 5, 7, and 8, you all agree? Yes. Okay, good. The next question, part 3. The complement of A intersection, the complement of B in brackets. Any volunteers to answer that question? Patrick?
It's a null set.
It's a
Null set.
null set. Good. No elements. It's a set that has no elements, so without any members. You all agree with that one? Right, 4. If you disagree, then say so we can check. Number 4, the complement of B union the complement of A the complement of B union A intersection the complement of B in brackets. Megan?
One, 2, 3, 6, 9.
1, 2, 3, 6, and 9 is correct. And the last one, number 5. A union the complement of A intersection the complement of B. Velma?
One, 2, 3, 4, 5, 6, and 9.
1, 2, 3, 4, 5, 6, and 9. Correct. Anyone wants me to do any of those on the board? Number 4, 3? Okay, then we'll do 3 and 4 together. Okay, number 3 first. The complement of A. 2, 3, 4, 5. 1, we had it here before. 1, 6, 7, 8, and 9. All right, the complement of B will be 1, 2, 3, 4. Oh, 1, 2, 3, 6, 9. Okay, that's the complement of B. The set A we know 2, 3, 4, and 5. So the question is the complement of A intersection A intersection the complement of B. Okay, first we have to find A intersection the complement of B. Okay, I'll just put them in. All right, A is 2, 3, 4, 5. The complement of B is here 1, 2, 3, 6, and 9. So A intersection the complement of B will be 2, 3, only those 2. So I have 2 and 3 here. The complement of A is here 1, 6, 7, 8, and 9. Okay, so I've got 1, 6, 7, 8, and 9, and 2 and 3. So the complement of A intersection this, there is none. So that would be a null set. So that should be clear now. Number 4. Okay, for number 4, we've got the complement of B here. We've got A on the screen, which is 2, 3, 4, and 5. Okay, let me just remove this. So we want the complement of B, right? Union A intersection the complement of B. Okay, first we have to find this. A is 2, 3, 4, and 5. The complement of B is 1, 2, 3, 6, and 9. This one will be 2 and 3. Agree? Okay. So the complement of B union 2 and 3, the complement of B is 1, 2, 3, 6, 9. So 1, 2, 3, 6, 9. Right, all of this included. Clear now? Okay, the next thing we are going to do is to look at two more examples. And then after that, we will look at exercise 6, which is based on, still based on intersection and unions, but when there are more than two sets. All right, I've got an example 2 here. The figure below shows two intersecting sets, A and B. The entries give the number of elements in each region. I already explained earlier that NA means the number of elements in the set A. Okay, so this 9 here represents this circle represents the set A, and it includes this number 9 and the 3 as well. So the number of elements in set A is 12. Clear? Okay. The number of elements in the set B, all right, the circle indicates that that's the set B, and because 3 and 7 are inside the circle, that means the number of elements will be this 7 plus 3. So that's why I've got 10 here. All right, the number of elements in the set A intersection B is clear. You all know how to read Venn diagrams. So the number that's in the middle indicates the number of elements that is in the set A intersection B. So in this case, it's 3. And number 4, the number of elements A union B is 19. Okay, that's altogether the number of elements in the set A and the number of elements in the set B. We get 19. In other words, you can also write it like this. It's the number of elements in A, just like you add, plus the number of elements in the set B will be equal to 19, because the number of elements in set A is 12, the number of elements in set B is 10. Now how did I get 19? It's 19, huh? It can't be 19. Is it 19? Oh, yes, because the intersection is 3. Okay. So it will be 19. You have to subtract, you're supposed to subtract A intersection B. So because this 10 and 12 will be 22, so it cannot be 19. So mathematically I'm wrong. Okay, you're supposed to subtract A intersection B. So it's 22 take away 3 is 1 plus 10, 9. Okay. Let's see if we can do this together. Out of 3 recreations, gardening and playing sport, 3 recreations, gardening and playing sport, 1 more. It's only, I've only got 2 on the board. Gardening, reading, and playing sport. 120 people were invited to state in which they were interested in. 60 were interested in gardening, 86 were interested in reading, and 64 were interested in playing sport. 32 gardened and read, 38 gardened and played sport, and 34 read and played sport. You are to find how many were interested in all three activities. Okay, this is the information we are given. The number of elements in the set gardening, union, reading, union, playing sports for letter S is 120. That includes everybody who was invited or interviewed, invited. All right, the number of people who gardened is 60. That's the information we are given. The number of people who read, 86. Number of people who played sport, 64. Number of people who read and gardened is 32. Number of people who gardened and played sport, 38. And the number of people who read and played sport, 34. Okay, can you work out the number of people who were interested in all activities? In other words, you are looking for N of what? G intersection R intersection S. Okay, can you do that quickly? Finished? Yeah. Because it includes, what does it include? Those 60 that were interested in gardening, they were also interested in something else. Because you are told at the bottom there, 60 were interested in gardening, 86 were interested in reading, and 64 were interested in playing sport. Those ones were also interested in other. It may have included the others who were also interested in other. Okay, GURUS is all of them. That's 120 people. Like for instance, that number of elements in A is 12, but altogether there are 19 of them. You get it? Yeah. may have been interested in something else too. Not just in gardening. That's why if you add, the number is more. But only 120 people were added, so that 60 includes, that's why you have to find G intersection R intersection S. Because that 60 might include other people who also were interested in something else. Any answers? $16 or $14? Could be 16. Could be, yeah. Could be 16. Yeah. I haven't worked it out. Okay, you will note here, this was the answer for number 4. And that was the number of elements for A in the set A union B. And what we did was we added these two and then we subtracted A intersection B, which is 3, and we got 19. You have to follow a similar method to do this. Okay, let's see if we can do this together. All right, 120 includes 120 includes everybody who was interviewed. Okay, so that's also equal to the number of elements in G plus the number of elements in R plus the number of elements in S, but we have to subtract. Okay, so what will we subtract? The number of elements in, okay, G intersection R. We also have to subtract the number of elements in G intersection S. Okay, and then we also have to subtract the number of elements in R, R intersection what? G? G or S? Oh, sorry, S. What else? What else do we need to do? Let's see. we have to add the number of elements in G intersection R intersection S. Okay, we are asked to find G intersection R intersection S. Okay, so that's 120. We already know this. That's 120 people altogether. All right, the number of elements in G, note, where it says the number of, where is it? 60 were interested in gardening. It might include some people who were also interested in sports or in reading. It's not just because if you add all of this, it will not be 120, which means those people also included those that were interested in other things as well. Okay, so 120 we know the number of G union R union S, number of elements is 120. Okay, we know that the number of elements in G is 60. The number of elements in R, interested in reading, is 64. The number of elements interested in sports is, sorry, this is 86 and then 64. Okay, we then have to take away the number of elements in G union R, which is G union R, 32. We also have to subtract 38, and then we have to subtract 34. Do we know the number of elements in G intersection R, which is intersection S? No, that's what we are trying to find. So it says I have to add that. So if I add and maybe make it equal to X. Okay, so 120 is equal to that 60 plus 86 is 146. 146 plus 64 is 210. Minus 32, what do I get? 98? 178? Take away 32, 140, take away 34, 106. So 106 plus X. X is equal to 14. So therefore, the number of elements in G intersection R, which is in intersection S, is equal to 14. You can actually use a Venn diagram to work it out as well. Okay, there are three things here. G, R, and S. You can use a Venn diagram and put the number of elements in each set, and you will work out the number of elements for this G intersection R, which is intersection S. All right, can you do number one quickly? 5 minutes. No worries, you have time. 2 minutes to do A and B. It's a very easy one. That's 12. Number of elements in B, that's 17. Number of elements in the set, or did you do C? Okay. A intersection B will be 5, and the number of elements in the set A union B will be 24. All right, for homework, you are going to do number 2, number 3, number 4 and 5, 6, 7, and 8. That's all. All right, the keyword to the pilot teacher is intersection 2.